Hello everyone. My name is Vijaya Singh. I am a student of Triple IT Jabalpur. In this video, we are going to introduce the topic of graph coloring. So, these are the contents that we are going to cover. Introduction to graph coloring, history of graph coloring, some basic terms related to graph coloring, algorithms for finding solution, its applications, some exercises for you, some useful links and some references. So, what is graph coloring? Graph coloring is a problem to assign labels called colors to elements of a graph subject to certain constraints. And the number of colors used for coloring the graph should be minimum. Then comes the history, origin of graph coloring. Problems related to coloring of maps of regions, such as maps of parts of the world, have generated many results in graph theory. While coloring, two regions with common boundary are assigned different colors. One way is to use different color for each region, but it is inefficient as number of regions is large. So, it would be hard to distinguish similar colors. And a small number of colors should be used whenever possible. For example, consider the following graph. Here A is connected to B, C, D and E, or we can say A is adjacent to B, or A shares boundary with B, C, D and E. So the problem is to color this graph such that no two adjacent regions share the same color. This can be done like this. Here, three colors are not enough for coloring this graph. So we have to use number of colors greater than 3. Each map in the plane can be represented by a graph where vertex represents regions of the map, edges connecting two vertices represent that these vertices have a common border. For example, here A is connected to B, it means A and B have a common border. So let us know about some contributions made by great mathematicians. In 1852, Francis Guthrie postulated four-color theorem. Then in 1879, Alfred Camp claimed proof for four-color theorem. In 1890, Haywood proposed five-color theorem. In 1976, Kenneth Appel and Wolfgang Haken proved four-color theorem. So let us study about types of graph coloring. First one is vertex coloring. It is the assignment of a color to each vertex of the graph so that no two adjacent vertices are assigned the same color. Then edge coloring. It is the assignment of a color to each edge of a graph such that no vertex is incident to two edges of the same color. Then face coloring. It is the geographical map coloring. It can be transformed into vertex coloring also. So, in this video, we will mainly focus on vertex coloring. So let's start by saying we have a graph G with vertex set V. A proper vertex coloring is the labeling of the vertex set such that F maps vertex set VG to a set of labels, maybe 1, 2, 3 up to K, where K is color such that no two adjacent vertices is assigned same color. For example, let's talk about 4 cycle with vertex set A, B, C and D. If I give these vertices colors, we can check if this is a proper coloring or not. So we just have to check every pair of vertices which are adjacent and make sure that they are not assigned the same color. But of course, the only time we have used the same color was on vertices B and D, and those are not adjacent. So this is a proper vertex coloring using 3 colors. If instead we color the vertices like this, we can see that it's not an example of proper vertex coloring because we do have a pair of adjacent vertices which are assigned the same color. But you may notice the proper coloring that I gave used 3 colors, but I can do this with only 2 colors. We color them like this. Now we can see that this is also a proper vertex coloring and we used only 2 colors. Now let us study about some terms related to graph coloring. K coloring. What is K coloring? K coloring of a graph is a coloring using K colors. If a graph has K coloring, then it is called K colorable. Consider this graph. Here we have used 3 colors, so it is 3 coloring. And now consider this graph. Here we have used 2 colors, so it is 2 coloring. Chromatic number. What is chromatic number? The chromatic number of a graph G, denoted chi G, is the smallest number k such that G is k colorable. Consider this example. Here we can color this graph using two colors, so the chromatic number of this graph is 2. If a graph G has chromatic number k, we say that graph is k chromatic. Now let us study about some properties of chromatic number. If a graph G has n vertices, then the chromatic number of the graph is at most n. Imagine just coloring every vertex of a graph with different color. The chromatic number of a graph G is 1 if and only if it has no edges. For example, if the graph has no edges, there is no problem in coloring all the vertices with the same color. But if you have an edge, you have to apply different color to n vertices of that edge. Next, let's think about cycles. The chromatic number of a cycle of even order is equals to 2 and the chromatic number of a cycle of odd order is equals to 3. You can think about this by doing coloring of 4 cycles. Just go around alternating colors 1, 2, 1, 2. Now the chromatic number of a cycle of odd order is 3. Like when you think about coloring with 5 cycles, just go around alternating colors 1, 2, 1, 2. When you get back to the beginning, you need to apply a third color. So the chromatic number is 3. Another extreme case is the complete graph. So the chromatic number of the complete graph of order n is equals to n. This makes sense because every pair of vertices is adjacent in a complete graph. So you have to use n colors in order to make proper vertex color. If H is a subgraph of graph G, then the chromatic number of G is at least as the chromatic number as H. This should make different sense because imagine you have a graph G and inside the small graph H. You need a certain number of colors to color that small portion. You need at least that to color the whole graph. For example, if you find a triangle inside your graph, then you know you need at least 3 colors to color the whole graph. A K coloring of graph G partitions the whole set V into parts V1, V2 up to Vk, where each Vi is an independent set. By independent set, we means that no pair of vertices is adjacent. This means V is equals to V1 union V2 up to Vk, and Vi intersection Vj is equals to phi for all I not equals to j. And these independent sets V1, V2 up to Vk are called color classes. To understand this, let us take the example of Peterson graph. Here, color 1 is red, color 2 is green, and color 3 is blue. You can see that no two red vertices are adjacent, so the red sets forms the independent set. Similarly, green and blue forms the independent sets, and the red, green and blue partitions the graph in 3 parts. Now let's study about algorithms for graph coloring. Algorithms for finding solution of graph coloring. No efficient algorithm available because it is a NP-complete problem. But there are some approximate algorithms also, like basic greedy algorithm, parallel and distributed algorithm, decentralized algorithm. So let us talk about greedy algorithm. In this algorithm, we first color the vertex 1 with first color that is available with us, and do the following for remaining V-1 vertices. Consider the currently picked vertex and color it with the lowest numbered color that has not been used on any previously colored vertices adjacent to it. If all previously used colors appear on vertices adjacent to V, assign a new color to it. Consider this example. We can color this graph like 0, 1, 2, 3 and 4. So, in this way, we have used 4 colors. But this graph can also be colored like this: 0, 1, 2, 3 and 4. So in this graph we have used 4 colors. We can say that this algorithm doesn't guarantee to use minimum colors, and the number of colors used sometimes depends on the order in which vertices are processed. Then comes the applications of graph coloring. There are many applications of graph coloring like making schedule or timetable. Suppose we want to make an exam schedule for an university. We have list of different subjects and students enrolled in every subject. Many subjects would have common students. The problem is how do we schedule the exam so that no two exams with a common student are scheduled at same time? And how many minimum time slots are needed to schedule all exams? This problem can be represented as a graph where each vertex is a subject and an edge between two vertices means there is a common student. So this is a graph coloring problem. Graph coloring has its application in mobile frequency assignment also. In Sudoku also. Graph coloring is used in register allocation, in bipartite graphs, in map coloring also. This is a small exercise for you people for practice. It's a simple exercise. You all will be able to do it. So just give it a try. These are the useful links that will be useful for you if you want to know more about graph coloring. These are the references that I have used during making of this video. And thanks for watching.